Welcome everyone back to our class. Oh, you are really study hard. Think about a tiny protein that can make or break your immune system. Sounds like a blockbuster plot, right? Well, meet IL-23. It's not just any protein, it's a master puppeteer in the world of inflammation and immunity, composed of two key players, P19 and P40. Let's dive into this drama. So, where does this IL-23 come from? It's built from two distinct blueprints. The P19 subunit comes from the IL-23A gene chilling on chromosome 12, while the P40 subunit is coded by IL-12B on chromosome 11. Think of it as a two-part instruction manual for building this inflammatory powerhouse. Its discovery was a bit of a slow burn, first described in 2000, then boom, in 2003, scientists realized it was the secret sauce behind IL-17 production, the signature cytokine of Th17 cells. And by 2005, they nailed it. IL-23 was the villain driving autoimmune chaos. Who makes it? The usual suspects like dendritic cells and macrophages, but also B cells, endothelial cells, even neutrophils get in on the action. It's produced wherever there's a party, especially at barrier tissues like skin and gut, and guess what? Inflammation cranks up its production. Alright, let's talk about how IL-23 pulls its weight. Its main gig is to be the bouncer at the Th17 club, making sure these cells multiply, stick around, and throw a rager-producing IL-17, IL-22, TNF-alpha, you name it. How does it work its magic? It latches onto a receptor combo, IL-12R beta-1, which it shares with its cousin IL-12 and its own specific partner, IL-23R. This binding flips the switch, activating JAK kinases, which then phosphorylate STAT proteins, mainly STAT3, but also 4 and 5. These STATs are like the DJ spinning the pro-inflammatory tracks, turning on genes for those nasty cytokines we just mentioned. But here's the twist. It's not just a one-trick pony. While it's famous for fanning the flames of autoimmune diseases, it also plays hardball against regulatory T cells, the peacekeepers, weakening their anti-inflammatory efforts. And yes, it even has a complicated relationship with tumors, potentially promoting them via the NF-kappa B pathway, though the exact script is still being written. Now, let's get to the juicy part, the clinical drama. IL-23 isn't just a lab curiosity, it's a major player in real-world diseases. Think psoriasis, rheumatoid arthritis, Crohn's disease, ulcerative colitis. IL-23 is often the instigator, the one lighting the fuse for chronic inflammation. It's even linked to lung fibrosis and gum disease. Because it's so central, it's become a prime target for treatment. We've got monoclonal antibodies like guselkumab and risankizumab that specifically block the P19 subunit and JAK inhibitors that shut down the whole signaling pathway. Here's a fun fact. IL-23 shares a subunit, 40, with IL-12, but they're polar opposites. IL-12 is more about the thone response, while IL-23 is the undisputed king of 17. Knocking out IL-23 in animal models can stop arthritis dead in its tracks, but removing IL-12 sometimes makes things worse. That really highlights IL-23's starring role in the inflammatory playbook. So what's the final word on our friend IL-23? It's a classic double-edged sword. On one hand, it's crucial for fighting off certain infections, like helping clear Helicobacter pylori. But on the other, it's a notorious troublemaker, driving chronic inflammation in autoimmune conditions and IBD. Its role in cancer is still a bit of a mystery, sometimes pro-tumor, sometimes not. The future looks promising, especially combining IL-23 inhibitors with those targeting IL-17, offering hope for patients who haven't responded to treatments before. Pretty dramatic stuff for a little protein, huh?